Okay, over the last several sections, I keep using the word simplifying a radical. So we've seen what that means in varying situations and varying ideas. But what I like to do before we move on any further in Chapter 10 is let me take this opportunity in 10.4 just to kind of go over all the rules for simplification. We'll talk about them and then we'll practice them one last time. That way we're really ready because we're going to just keep building on this. So we should make sure we know what we're doing and why my math lab keeps saying you're wrong in some certain situations. So here's why. All right, so to simplify a radical, right, we consider a radical not to be simplified until all the following conditions are met. And I even think that's a fourth one right there. But the first condition is that the radicand, so that's the item that's underneath the radical, has no power, and maybe say powers, higher than the index. So when I look at these two radical expressions, here the index is 3, right? And I can see a power of 5, and that's a power of 3, so it's equal to, right? But it's not higher of the index. And even 332 is 2 to the 5th if we broke it down into its prime factored form. So we're dealing with a situation where my powers are higher, or at least equal to the radicand. And so we simplify that. Again, I like to use the shortcut, but for those, we're trying to match. Basically, this is 2 to the 3rd, 2 squared, a to the 3rd, a squared, and we already have a b to the 3rd. So we can basically see that I have situations where my power matches the index. And so we're left with, we get a 2 that comes out of this, an a that comes out, a b, and then underneath the radical we still have a 2 squared, which is 4, and an a squared. So there would be the simplified version of that radical. Notice the radical that's left, none of the powers, this is 2 squared and this is a squared, the powers are now less, right, than the index, so we're simplified. In the next example, the index is 4, and I have a power of 12, and that's a power of 9. All right, so I basically have two powers that are higher than the index. So again, if I'm using the shortcut, I'm thinking 4 goes into 12 3 times. So I'm going to have a y cubed, and 4 goes into 9 twice, the remainder of 1. So 2 of these will come out, 1 will stay in. But if you just want to break it up to match powers, that's what it would look like. And so we can see a power of 4 there, there, and there. So we got a y cubed. I see a power of 4 here, and I see a power of 4 there. So we have y plus 2 squared. And then what remains in the radical is there's 1 y plus 2 remaining. So there would be the simplified version of that radical based off of this simplification rule, that no powers are higher than the index. All right. The next thing that we don't want to happen is that the radicand contains no powers. The radicand's powers do not share a common factor. So that's also another condition for simplification. So in this case, the index is 8 and the power is 6. So this rule is satisfied, right? The power is less than, but 6 and 8 share a common factor. So the official way to do that is to break it up into the fraction that it is, right? So we can rewrite this as the 6 to the 8th power, reduce that fraction, and then follow our rule, right? We're going to match. We started with a radical, so we'll end with a radical. So there would be the simplified version of that guy there. Again, it satisfies the first rule, the power inside is less than the index, and it satisfies the second rule, that they do not share a common factor. So we're simplified. Here's a problem that we had a while back. I asterisked and told you guys we're not done yet. And the reason why is because, again, the powers are not higher. That's the good news. But 4 and 2 share a common factor. So officially, again, we're talking about y to the 2/4 and y plus 2 to the 2/4, right? Because that's what that essentially becomes. And so we're looking at y to the 1/2 and y plus 2 to the 1/2. So essentially, we're talking about the square root of y and y plus 2. So now we satisfied both conditions. The power is 1, so that's less than the index, and 2 and 1 don't share any common factors. So that is now simplified. Of course, what we have learned in this particular section is that no radicals can be in the denominator, and that kind of creates a fourth rule, which means none of our radicands can be fractions. And so we actually kind of have a twofer there, and although I'll split them up. So this guy is not simplified because there is a radical down in the denominator. So we need to simplify it by rationalizing it. What we've learned is we need to multiply, right, by build an equivalent fraction. I need an 8th root, and we have a power of 1. So I need a power of 8, so I actually need the 8th root of x to the 7th. If we multiply, we get the 8th root of x to the 7th down here, and the 8th root of x to the 8th, right? Keep the exponent, keep the radical x times x to the 7th as x to the 8th. Power matches the index, so there would be the simplified version of this fraction. Okay? This one has the problem that the radicand is actually a fraction. So we've learned that we can break that up into pieces. And now we've created the second idea that my radical is a denominator. So that kind of demonstrates why this rule and this rule are kind of embedded. Because as soon as, if we have a radicand that's a fraction, we break it up, and then we now have the idea that my denominator is a radical. Simplifying this, the top, we can rewrite that as 2 to the 4th. Right? And so using my shortcut, 3 goes into 4 one time with remainder of 1. So we're going to have 2 the 4th root of 2. Of course, you can think of that top as 2 to the 3rd times 2 in the cube root. And so there's the top. Oops, that should be a 3. And we have a cubed root of x down on the bottom. So we've simplified the top as much as we can, right? We had that rule to contend with. It's been worked on. And now we have the radical down below. So I'll multiply both top and bottom by a cubed root. And in this case, we need x squared to match the power. So upstairs, when I do all the math, these two multiply up to the cubed root of 2x squared. And on the bottom, we have the cubed root of x to the 3rd. Power matches the index, so let me write the answer a little bit over here. I'm running out of room. So we get 2, the cubed root of 2x squared all over x. And there would be our final simplified version. This radical that remains satisfies everything, right? The powers are less, they're not higher than the radicand. They don't share a common factor. The radicand is not a fraction, right? We're talking the radicand. The answer is a fraction, but I'm saying the radicand can't be a fraction. And then there's no radicals down the denominator. So nice and simplified. So those are our big 4 rules. How about we cut to another video where we continue to practice using them in various situations.